Capstan Ag is very excited to introduce our new product called Tattler. It's an electronic row flow monitoring system. It combines with our Pinpoint 3 rate controller, does flow distribution, individual electronic row flow monitoring, and also includes the check valve down at the point of application. So we'll take a little bit closer look at this system. And these are sort of the primary parts that comprise the Tattler system. One of them, the electronic unit right there, that is our rate controller, which would be mounted on the toolbar. The next one is what we would call the Tattler row unit. So this row unit right here is what does all the flow distribution. So you mount these at every row on your toolbar. It has an inlet for feed, as you can see on the top with a dry boom. It has an outlet on the bottom, which uses a really nice push to connect fitting, goes down into our super check valve. And this super check valve is a new design. We really opened it up. It's a very, very high flowing check valve. And the reason we did this is we wanted to have to be able to produce really, really high flows. So you're looking at a combination right here that I think will outflow just about anything on the market. It's capable of producing a tremendous amount of flow. And this new check valve design allows for extremely high row-to-row accuracy while doing those high flows. Along with all of that, it is an ISO-bus system, so it'll put into your ag leader monitor as depicted here. It'll run in any of the standard ISO virtual terminal task controllers. So whichever one you have in your cab, we plug right into it, pull up on the ISO. You can see down at the bottom, there's that bar graph at the bottom that tells you the status of each individual row that is flowing. You can see in this example, it's saying that the row number 3 is flowing lower than the rest of the rows, so it's giving you a fault on that row. So again, it's doing the rate control, it's doing the distribution, it's doing the row flow monitoring. It serves as the distribution system and has a really nice, easy to use operator interface. Now we'll take a lot closer look at the individual parts here to see exactly how they function. This is a quick introduction to the Tattler row unit. So this row unit right here, it has a top and a bottom to it. This is the inlet. You can tell the inlet because it has 3/4 inch NPT pipe fittings in here. So that is so you could screw, if you're running your dry boom and you want to run the 3/4 inch hose in between the bodies, you just get a 3/4 hose barb T to 3/4 NPT. You can screw it right into this fitting. If you prefer to use flange type fittings and flange Ts, that's no problem. You can see that the top of this is a standard flange fitting. So you have the option to use threaded fittings if you'd like to use those. You can use the flange fittings if you like those as well. On the bottom of this row unit, this is the exit side of the row unit. You can see that it has a 1/2 inch PTC connector. So we use the larger 1/2 inch push to connect fitting because that 1/2 inch push to connect hose has about the same outside diameter as a 3/8 hose, but it has a much greater inside diameter, or it allows a lot more flow to come through it. So we can get a lot more flow from this body unit down to the row unit just because we've opened up that hose. And again, you can tell with just the inlet to this body right here that we have a tremendous amount of inlet flow capacity. So again, inlet flange fitting. On the outlet, you've got this push to connect fitting that you can use, but you can also see that it has a flange fitting on it as well. So if you have some style of flange fitting that you would prefer to use on the bottom of this, you're welcome to flange both the top and the bottom of this fitting. So your mounting options for this are pretty universal. You can pretty much bring any plumbing you want into it, flange or pipe, and you can pretty much take any plumbing you want out of it, push to connect or some type of flange fitting. So really nice, really easy, universal design there. The next part of this valve is where the electronic row flow monitoring happens. So this is where we house the plunger in this tube right here, and you can see that it has a 6-pin DT connector on it. So this is there's a sensor in here, and this is how we power it up, and this is also how we send diagnostics from this sensor back to the isobus controller. So again, this part just screws right out of here. And when you open this up, you can see that this part right here is hollow. There's nothing in it. But inside of this body right here, we have a plunger and a spring. So, and we can just take those two components apart. So this plunger right here sits inside of this body, and you can see the hole right there. So the plunger sits in that body. This spring sits on top of that plunger, and then that spring gets compressed a little bit by this body as it goes on the top. Now, as we are flowing, I'm just going to stick this pick in here to demonstrate. This body right here, as the flow comes through, it lifts this plunger up. So you can't see, it doesn't get a tremendous amount of lift. Maybe if I tilt it to the side a little bit, you can see as I push up, or the flow would be coming through this unit, it actually lifts this plunger up. And so this cap sits right on top of this plunger. We have a sensor embedded into the top of this plunger right here, and we have a pickup sensor embedded into the top of this cap right here. So as that plunger moves, or as that plunger lifts, we can detect that height. The more flow that's coming through here, the higher it pushes that plunger up. The higher it pushes that plunger up, the more flow that we know is coming through. So again, this is a very new, very unique way of doing row flow monitoring. You can see it has some slots cut into this plunger right here. Might be easier to see if yeah, there we go. You can see that it has slots cut into it. They're very wide slots. They're very open. This means that we don't have to have really tight tolerances for anything. We can flow a lot of trash through here without causing any issues at all. So we can move a lot of flow, we can move a lot of trash, and we do electronic row flow monitoring. There are no moving parts. You know, like a turbine flow meter that's spinning around in a circle. There's no moving parts to this. It simply has basically a magnetic sensor in it, and as it raises and lowers, we can detect that height. So none of the electronic parts get wetted, which means that they're going to have a really long life and be really durable. So again, a really, really simple, really, really unique row design here to do your row flow monitoring. And your row flow monitor serves as your point of distribution as well. So that is our valve body. And next we'll introduce the row flow module that picks up the signals from this. The next piece of the Tattler system that we have is just the electronic module that allows those row flow units to communicate back with the rate controller and then put that row flow diagnostic up on your isobus screen. So the module is really, really simple. We've got two 8-pin connectors, 8-pin DT connectors on either side of this. You can see this one down here says sensors 1 through 6. This one says sensors 7 through 12. So this would plug into rows 1 through 6 and get those flow meter signals back to the controller, or those plunger height signals. We'll call it a flow meter because it does measure the flow. And this one the other side of it grabs the other 6. So there's 6 pins to pick up those signals, and then there's a power and a ground. So that's why we have 8 pins, 1 power, 1 ground, and then it shares that power and ground to all those sensors on the harness plugged into here, and then it picks up those signals from those. So again, both of these sides are identical. It just, each one of these modules can detect up to 12 rows of flow. So we just mount these on the toolbar. Along with these, there's some very simple diagnostics. You can see there's some LEDs in here. We can tell if we've got power. We can tell if we've got CAN communication. We get a status indicator on there. There's some diagnostics built into this in case you have a pinched wire on your toolbar or something like that later on down the line. So some basic diagnostics built into this, some visual diagnostics, and then again, there's a 6-pin connector right in the middle of this, and we run a extension harness from here just back to the rate controller so that it can communicate with the rate controller. So very simple row flow detection module, plugs in to 12 rows. If we have more than 12 rows, we just add another module and plug into another port on the hub, so we can just keep on stacking these modules up for however many rows we have, and run an extension back to the hub. So the electronic row flow module is a pretty simple module, pretty easy to mount pretty much anywhere on the toolbar. Typically mount it in the middle of the rows that it's going to be plugged into. Pictured here is our row flow monitoring harness. So I've got the sense module in the middle, just like we talked about. So this is that 8-pin connector. This would be running down your toolbar. Again, it would just plug into one of these right here, and it would control up to 6 rows. And again, this can plug into either side depending on which way you're running your rows. And so this harness runs out to the each individual row, or to each individual row flow device. And then this harness has a 6-pin dropout. And we make a bunch of different versions of these. So we have one where these drops are on 20-inch spacing, 30-inch spacing, 40-inch spacing. So depending on how your toolbar is set up, you would just simply mount the row flow module on your toolbar, plug in your harness to pick up your row modules, and then you would plug your row module into your flow detection, your Tattler row unit. So the harnessing is pretty straightforward, pretty simple. The last part of this is an extension harness we talked about. So this is really simple. It's a 6-pin connector. It plugs into this module, and then it just routes back to the hub so that it can communicate its flow control information to the hub.